Last time in my class, we learned how the working principle of a potentiometer. In today's lesson or in today's teaching, I am going to teach the advantages a potentiometer has over a voltmeter. That's what we have on the board. We are going to learn the advantages a potentiometer has over a voltmeter. I don't want this video to be long because of some certain reasons. I'm going to go straight into the point and explain a few things to allow us enjoy the flow. Of course, we have learned this. We have understood how this works. That's very important. The next thing I want us to learn is one or two or three advantages that a potentiometer has over a voltmeter. And without wasting time, we are going to consider these three advantages of a potentiometer against a voltmeter. So before I move into all the details associated with this, let me once again remind you that if you do not need this, think of somebody, think of a child, think of a student somewhere, think of learners that are in science line that might need this. Share it with them. Share it with them. It costs you nothing, just a fraction of seconds. You tap the button and it takes on. Put on the bell button for constant notification so that each time things like these are uploaded, you'll be notified. You just receive alerts that Dr. Kingsley has posted a new video on so topic. That's awesome. Remember to give us some thumbs up. It will take you anything. All right? Okay, thank you. I must also thank my returning subscribers, my new subscribers. Without you, this channel will not thrive. So, kudos, thumbs up for you as well. Please do the needful for me once again. Share with your networks. All right, so let's go back to this. What do we have here? Very simple explanation. And let's begin with number one. Look at number one here. That the potentiometer measures EMF when the cell gives no current. So when the cell gives no current, it measures it. That's an advantage. And the records an accurate value, look at it. And the record an accurate value of the cell EMF. Since no lost voltage happens across the resistance. There is no lost voltage. Unlike what we experience when we are talking about internal resistance and the rest of it. Okay? But while using a potentiometer, you will never, the entire system will never experience any sort of lost voltage or potential drop somewhere. That's what explanation number one is all about. The second explanation here, or the second advantage over a voltmeter that a potentiometer has, is that voltmeter takes current from the cell. A voltmeter takes current from the cell. And by the time it takes current from the cell, what happens? It means it depends on the current taken from the cell, and it might not give a high accuracy. Okay, it will fail in giving a higher accuracy because of this error associated with the pointer reading. That's why it takes current from the cell, all right, and then fails to give a high accuracy value. That's what happens. But you have no such problems with a potentiometer. A potentiometer does not record any error, doesn't measure any error. It gives you accurate reading or measurements. So that is also an advantage, second advantage. All right? Now let's look at the third one. The third advantage. Look at this. Very simple. I hope you're still there. Look at this. The potentiometer measures the EMF of the cell to a higher, all right, to a higher degree of precision. Perfect. A higher degree of the precision. Perfect. No errors associated with it. But, look at that. A voltmeter may record a zero error in the reading. So a potentiometer has an advantage again over a voltmeter because the voltmeter will always record zero error in the pointer reading. We can call it parallax error or any sort of error. But our concern here is that there is something a potentiometer does over a voltmeter. That's what it means. All right? So, we are done with that. With these three advantages, once you have a potentiometer and you want to compare the EMFs of different cells, you will get an accurate value or accurate values. All right? So take note of that. But a voltmeter may not be used to compare. Of course, that's another advantage. A voltmeter may not be used to compare the EMFs of different cells. You can do that with a voltmeter. So that's what we are trying to say here. That's the picture we have created here. All right? So that is it. For having watched up to this moment, thank you. Thank you so much for your patience and watching up to this moment. I repeat, thank you so much for your patience and for watching up to this moment. Then, do not forget, thumbs up, subscribe, share with those students of yours, friends, networks that need things like that are in science line, physics, chemistry, mathematics. Share with them. They need things like this. Put on the bell button for constant notification. All right? Do not forget. Oh, come on. Now, I am done with that. Okay? Those are the things I wanted us to learn in the first place. Now, in my next video, which will be linked or connected along this side or that side, I'm going to solve this problem. I will take time and solve this problem. You will now see how to calculate different EMFs of two different cells. The problem here is, suppose the current in a potentiometer is adjusted with a rheostat so that the galvanometer reads 0 when the standard cell is 1.3 volts along 55.0 cm wire. That's what it means. When you point at this is jockey, sorry I didn't say this in my last video, but I think nothing is late yet. It's jockey. This jockey slides on a uniformly calibrated meter rule. Alright? So what the question says, as the whole thing is set up and current begins to flow, what happens? In a potentiometer, but this current is being adjusted, okay? It's adjusted by a rheostat. Once it's adjusted, the slider or the jockey is slide at a point 55. This 55, the potential drop record is 1.30. Suppose this is 55, all right? At this point, the potential drop is 1.30. That's what we're trying to say. And then it continues again until the slider records another mark 64 cm. Then the question is, what will be the cell, the EMF of the unknown cell, or of the cell whose EMF is not known? C1. That's what is it. So, in my next video or in my next class, I will be solving this question. Alright? I will solve it and then link it to this video so that after watching this, you will now watch and learn how to solve a question like this, especially when such a question is connected with a potentiometer over a voltmeter. I want to end it here and then thank you so much for staying put up to this moment. See you in my next class where I'll be resolving problem number 1. Come on. I'm out. I'm out. All right.